Okay, our first step in completing the square is moving that constant to the right side of the equation. So minus that 60, x squared plus 16x equals negative 60. So then I'm finding a number that's half the middle term, so 8, and I square that. I add 64, not 16, 64 to both sides, and I end up with 4. Square root, x plus 8 equals plus or minus 2. Subtract the 8, x equals negative 6 and negative 10. Could we have factored that one? Yeah, we could have. Sorry, go ahead. Okay. For the next one, x squared minus 10x equals 7. What number goes in my perfect square? Minus 5. You got elves bothering you back there? He's got elves in his hair, apparently. Add 25. Add 25 equals 32. Now I square root x minus 5. Does 32 square root? No, but we can reduce it. So 32 is 8 and 4, 4 and 2, 2 and 2, 2 and 2. What can I pull out? 2 sets of 2. Oh, sorry. I'm going too fast. You can, but you might not always notice that. So she's asking, if I had 72 and I did 2 and 36 and 6 and 6, can I pull out a 6? And the answer is yes. But if you factor it a different way, you might miss that. But then you'll factor it down and get the right answer anyways. So if you see a perfect square, go ahead and use it. So you don't have to finish it if you see that. Okay. Plus or minus, we've decided we pull out a 4 and a root 2. And we add 5 to that. Can I add 5 to 4 root 2? It's just 5 plus or minus 4 root 2. So x equals 5 plus or minus 4 root 2. What if this would have been a negative 32? How would that change my answer? It would be 4I root 2, and that's the only difference. You nailed it, and you didn't even have to duck and cover? Okay. So, is number 2 factorable? Not really. I mean, you could factor into x minus 5 plus 4 root 2 and x minus 5 minus 4I root 2, but I wouldn't have been able to figure that out in my head. Okay. Well, let's suppose that I don't like completing the square. So let's suppose that I have ax squared plus bx plus c. What are the roots of this quadratic? Well, this represents every possible quadratic. So every possible root is inside there. We can create a formula where we don't have to complete the square. All we have to do is plug them in. So this is the formula that you can use to plug in any quadratic ax squared plus bx plus c. And the formula comes from completing the square. We chose completing the square because it always works. But some people prefer a formula as opposed to a set of steps. Yes? Okay. So this formula will complete the square for us. But sometimes we need complete the square to do other things. But if you're finding roots, you can choose between completing the square and quadratic formula. They do the same thing. But when we deal with circles and parabolas and ellipses and hyperbolas, sometimes you need to complete the square without finding the roots, and the quadratic formula won't help you out there. So if I gave you x squared minus 7x plus 20, I could complete the square to find out where this equals 0. Or I could just plug the numbers into the quadratic formula, and it will give me the same answer. The only difference is when you do the quadratic formula, there's sometimes a little bit more simplification. Yes? Yeah, so let's plug this in. So A is 1, B is negative 7, and C is 20. Okay? So negative B is the opposite of negative 7. So 7 plus or minus the square root. B squared is 49 minus 4 times A is 4 times C is 80. So minus 80 over 2. So this is 7 plus or minus the square root. What is that? 31. Negative 31. Negative 31 over 2. Does negative 31 simplify? No, so my answers are x equals 7 plus or minus I root 31 over 2. Okay? The nice thing about the quadratic formula, if you have a leading coefficient, completing the square is an absolute mess. But if you have a leading coefficient, then the quadratic formula is not too bad. So if you have a non-factorable quadratic with a leading coefficient, like 4x squared or 7x squared, use the quadratic formula. If it's a 1, then you can complete the square. So let's try another one. We'll do a big one. Okay, so negative b. Negative b is 7 plus or minus the square root 49, and then it's negative 4 times 1 times negative 170. I'm going to guess 580. 680. How did I do? 680. So plus 680 over 2. What's 49 plus 680? 7. So 7 plus or minus the square root of 729 over 2. Is 729 a perfect square? I sure hope so. Yes? So 7 plus or minus 27 over 2. What is 7 plus 27? 34 divided by 2? 17. 7 minus 27 is negative 20 divided by 2 is negative 10. Could I have factored this one? I could have. It works either way. Okay. Let's just do a random number quadratic. Give me a random number. 9x squared plus 12x. Oh, this is going to be ugly. Plus 13. Okay. Negative b. So let me write my formula down. Negative b plus or minus the square root of b squared minus 4ac over 2a. So negative 12 plus or minus the square root b squared. This is a, b, and c. So b squared is 144 minus 4 times 9 times 13 over 2 times a, which is 9. So negative 12 plus or minus, what is 144 minus all of that? 324. Oh, this is 324? Okay, so I'm right. Negative 324? Okay. Over 18. So is 324 a perfect square? I don't think so. 18 and 18? Really? Good guess. Nice job on that plus 13. All right, so negative 12 plus or minus 18i over 18. Okay, now I can't add those together because the 12 and the 18, one's real and one's imaginary. But is there a number that goes into 12 and 18 and 18? 6. So I can divide everything by 6. Negative 2 plus or minus 3i over 3. That's the answer there. Okay. What if I would have ended up with, say, 16 plus or minus the square root of 224 over 12? If you end up with something like this, we factor down 224, 4 and 25 and 6 is 31. Is that right? Four and 31? Oh, no, that's not right. Okay. 56. Thank you. 2 and 2, 8 and 7, 4 and 2, 2 and 2. So I can pull out two groups of 2 with a 14 left over. So 16 plus or minus 4 root 14 over 12. Can I simplify that? What can I divide everything by? Do I change that root 14? No, I do not. But I can change its coefficient. So 4 goes into all of those. So 4 plus or minus 1 root 14 over 3. And that would be my final answer. Okay? Your assignment today is this worksheet. Everything here is real, except you see on number 13, it says not a real number. So when you solve 13, I want the imaginary answer.